Business Intelligence and Analytics, From Big Data to Big Impact. Precursory group presentation created by Charles Sauché, Carly Sturm, Carmen Schern, and Stephanie Kane.
Hello and welcome to Business Intelligence and Analytics, From Big Data to Big Impact. Introduction. Significant developments have been made in the field of BI and A since the 1970s. We will discuss the evolution, application, and emerging research. We will also discuss the mapping of the BI and A knowledge landscape. Also, in the shortage of data savvy managers and business professionals with deep analytical skills, we will also discuss education and developments in the field.
Database management and warehousing is the foundation of business intelligence and analytics. This data-centric approach involves the collection, extraction, and analysis technologies. The timeline and evolution have vastly transformed the landscape of data processing and analysis. Utilizing tools for well-established business reporting functions, statistical analysis, and data mining techniques are implemented for association analysis, data segmentation, clustering, classification and regression analysis, anomaly detection, and predictive modeling for a various business application.
There are many different global business and IT trends out there which have helped to shape both past and present BI and A research directions. Items such as international travel, high-speed networks, global supply chain, and outsourcing have created massive opportunities for IT advancement. From the implementation of the internet in the 1970s to the large-scale adoption of the World Wide Web in the 90s, the amount of data being generated has increased at a near exponential rate. Most recently, the big data era has come upon us, and businesses from government, e-commerce, and health organizations have an opportunity here to utilize this detailed, rich, and complex data to lead to exciting new science, discovery, and insights. Business intelligence and analytics, or BI&A, is not only a data-driven field, but also is highly applied and looks to leverage opportunities which stem from the abundance of data and domain-specified analytics. These high-impact BI&A applications are listed on this slide below. These include things such as e-commerce and market intelligence, e-government and politics, science and technology, smart health and well-being, and security and public safety. By focusing upon the application and data characteristics, researchers as well as practitioners can decide on appropriate analytical techniques to help focus their impacts. IS departments are also facing both unique opportunities as well as challenges in developing BI&A research and integration, as well as educational programs for this new generation of data analytics and business-relevant studies. Big data excitement has primarily stemmed from both the web and e-commerce communities and organizations. There's been significant transformation by larger vendors that we all know and love, such as Amazon and eBay, with their innovative e-commerce platforms as well as their product recommendation softwares. Other players, such as Google, Facebook, and other social media sites, are leading in the development of web analytics and cloud computing through social media platforms. These forums and systems have led to the emergence of vast amounts of computer-generated content, which provides an opportunity for researchers and practitioners to listen and learn from consumers and others. The mass amounts of data and transactional records collected from these e-commerce systems differ greatly from that of the legacy system data from the 1980s. Today's data is far less structured, more vast, and often contains rich customer opinions and behavioral information that wouldn't have even been imagined in the past decades. There are numerous analytical techniques out there that have been developed for product recommender systems, including things such as association rule mining, database segmentation and clustering, anomaly detection, and even graph mining. Text and sentiment analysis are often used for social media analytics specifically. All of these things have led to opportunities in market intelligence, allowing for the reaching of niche markets, normally at the shallow end of the consumer and product pool, through targeted searches and personal recommendations. What's often referred to as Web 2.0 has stemmed changes from the normal forms of government and politics. The U.S. elections of 2008 actually showed the first signs of success and changes to campaigning being done mostly online, as well as participation within campaigns and the general election. Sometimes referred to as Politics 2.0, politicians and their teams are making use of highly participatory forums and multimedia web platforms in order to hold large-scale policy discussions, advertisement, as well as encourage voter mobilization and fundraising efforts. Techniques in analytics, such as opinion mining, social network analysis, and social media analytic practices, can all be used to better support political participation and even e-government service delivery. All of these can actually be used in conjunction with one another to lead to higher levels of transparency and accountability within the often jaded political landscape. E-government research is less common than the previous e-commerce research because it involves specifically political science and public policy researchers. However, what research has and is being accomplished actually shows great innovation, especially with another election coming up this year. The entire fields of science and technology have benefited from newer and better data being collected. Certain fields, such as astrophysics and oceanography, as well as genomics and environmental research, have especially profited from sensors and instruments providing levels and types of data they never had access to before. These massive sets of data are typically analyzed through domain-specific analytic methods, as each field has different needs according to their datasets. The data often undergoes high-level mathematical and computational analytics to try and make sense of the information and find a way to apply it. The National Science Foundation, or NSF, recently mandated an information sharing and data analytics initiative requiring researchers to provide data management plans. The 2012 NSF Big Data Program was part of the U.S. government funding agency's attempt to promote big data analytics. It aims to advance technological means of managing and analyzing massive datasets to help accelerate scientific discovery progress. This effort can help lead to newer fields of inquiry and research which would not have been possible without the development of new data analytic tools and algorithms. The community is working with an overload of content generated from multiple points of entry and coming in many different forms. Two of the main sources of health big data include genomics data and payer-provided big data. The obvious concern regarding health big data involves privacy and ethical concerns when it comes to HIPAA and other requirements out there. Health big data seems to be further behind than other e-commerce BI&A applications because of its failure to take advantage of some of the scalable analytical methods that are out there. Electronic health records are a great area of increase in application for BI&A worldwide. These datasets can be used by healthcare providers to provide a better understanding about patient disease patterns and even utilize predictive analytical methods. Health social media sites have also become more and more common in the recent years, and these provide researchers and patients with opportunities to support themselves and others. This is shown to be especially helpful for those with chronic diseases. Promising areas of research and analytics in health and well-being include methods such as association rule mining and clustering, health text analytics, health ontologies, patient network analysis, and adverse drug side effect analysis. Another recent NSF initiative is the NSF Smart Health and Wellbeing Program, or SHB for short. This program aims to help support the transformation from reactive to proactive healthcare methodologies. Rather than purely focusing on disease control, the medical community can work to focus on well-being with evidence-based, patient-centered care. Security research has understandably gained steam since the tragic events of September 11, 2001. Researchers in fields across industries have been called upon to enhance our country's ability to better fight violence, terrorism, and cyber-related crimes. This eventually led to the much-needed development of security informatics. The intelligence community gathers large amounts of data from many different sources and in many different types. Most of this data is complex and unstructured. However, there are BI&A technologies out there, such as criminal association rule mining and clustering, criminal network analysis, spatial temporal analysis and visualization, multilingual text analytics, sentiment and effect analysis, and cyber attacks analysis. A great example of this is the University of Arizona's COPLINK and dark web research programs. These both offer strong examples of crime data mining and terrorism informatics. COPLINK specifically is an information sharing and crime data mining system first developed with funding from NSF and the DOJ. It's currently in use by over 4,500 police agencies in the US and by 25 NATO countries. Their dark web research program was funded as well by NSF and the DoD and has generated one of the largest academic terrorism research databases out there. It's also responsible for the development of several advanced multilingual social media analytics techniques. All of these things together can lead to an increase in safety and security, as well as lead to better methods of predicting and preventing attacks.
The next portion of the article is about the business intelligence framework related to foundational technologies and the emerging research and analytics. There are 5 main sections that the article mentions: big data, text, web, network, and mobile analytics. They all kind of grow off of each other. In the upcoming slides, I will go into more detail about each of these and how they impact the business analytic community and individual organizations. This article is from 2012, so there have been much more studied in this section since then, especially in web and mobile analytics. Big data analytics is the stepping stone for business analytics. This refers to the data mining and basic statistical analysis that allows us to determine trends and patterns that can help make strategic decisions. Data mining and statistical analysis through large amounts of unstructured data needs algorithms set up to be able to do it efficiently. The article speaks about the 10 most popular algorithms used back in 2012. Overall, they focus on classification, clustering, regression, association analysis, and network analysis. The evolution of data mining has occurred because so many places have started automating processes and keeping digital records. One of the industries that the article mentions is healthcare. Think of how much data is accessible from a patient's medical chart and how useful that could be for medical studies. But it also brings into the question security. We have laws enacted to protect people's privacy, but this field is evolving very quickly to keep up and maintain security many times. Text analytics is the automated process of translating large volumes of unstructured text into quantitative data to discover any trends and patterns. Its roots are in information retrieval and computational linguistics. This builds on data analytics because the majority of content collected by an organization is in textual format, and it needs to be converted to something that can be analyzed quickly by a computer. Since the early 1990s, search engines have evolved into mature commercial systems, consisting of fast, distributed crawling, efficient inverted indexing, in-link-based page ranking, and search logs analytics. Many of these foundational text processing and indexing techniques have been deployed in text-based enterprise, search and document management systems, and business intelligence and analytics 1.0. Question and answer systems involve different techniques for question analysis, and that is what has evolved into Apple Siri and Amazon's Alexa. Web analytics is the collection, reporting, and analysis of website data. Usually the focus is on identifying measures based on certain key performance indicators for individual organizations or companies. Web analytics is built on data mining and informational retrieval of text analytics. One of the more popular uses is Google Analytics, where you can look at how many clicks per view and to better understand your website to optimize and check the performance of your marketing, content, or products. A major emerging component in web analytics research is the development of cloud computing platforms and services, which include applications, system software, and hardware delivered as services over the internet. Network analytics involves the analysis of network data and statistics to identify trends and patterns to help operators act on that data. Recent network analytics research has focused on areas such as link mining and community detection. In link mining, one seeks to discover or predict links between nodes of a network. Within a network, nodes may represent customers, end users, products, and/or services, and the links between nodes can represent some sort of social relationship or interaction. With network analytics, you are able to understand your network better and are able to mitigate any internal or external threats to that network. Mobile analytics is the practice of collecting user behavior data, determining its intent from those metrics, and taking action to create retention, engagement, and conversion on your mobile application. Google Analytics has a mobile version as well to run analytics. It is not only for web analytics. With the use of smart devices increasing steadily, the amount of data that is available is staggering. That data is very valuable to the people that are in charge of advertising, application gaming, and social marketing because the data is highly personalized, fine-grained, location-specific, and context-aware. Social, behavioral, and economic models for gamification, mobile advertising, and social marketing are underway and may contribute to the development of future business intelligence and analytics 3.0 systems.
A study into relevant business intelligence and analytics publications, scholars, disciplines, and other literature was performed in order to understand what kind of information on the topic was available. The largest and most reputable sources were Web of Science by Thomson Reuters, which covers more than 12,000 sources, Business Source Complete by EBSCO, which covered peer-reviewed journals and other sources like industry and trade magazines, IEEE Explore, which stands for the Institute of Electrical and Electronics Engineers and allowed for access into their libraries, Science Direct by Elsevier, which allowed access to 2,500 journals from the scientific, technical, and medical literature communities, and lastly, Engineering Village, also by Elsevier, which allowed access to ACM conference journals. In order to achieve consistency, the authors only selected data using a few key phrases: business intelligence, business analytics, and big data. As we can see from the graph, over the last 10 years, publications containing the key phrase business intelligence have tripled, with the key phrases business analytics and big data finding 0 publications for the first year and some subsequent years for big data. They claim this is because the wording big data and business analytics did not start to gain much fame until 2007. Although the list of contributors is long, we have provided the top 3 from each category. For top journals, conferences, and industry magazines publishing academically, the Conference on Business Intelligence and Financial Engineering took top spot with 531 publications. The Hawaii International Conference of System Sciences came in second with 370 publications. And third place went to the Conference on Electronic Commerce and Business Intelligence with 252 publications. Publishing for the industry was Computer World with 282, Information Today with 258, and Information Week with 229 publications. The major information systems journals were Decision Support Systems, Communications of the AIS, and Journal of Management Information Systems. And the top academic authors were Hishun Chen, University of Arizona, Shanghao Li, Zhejiang University, China, and Yang Shi, University of Nebraska. Business Intelligence and Analytics Educational and Program Development section discusses BI&A education in business schools, the problems some information system departments face, and business intelligence and analytics program development opportunities. In 2012, Columbia University implemented an $80 million investment into a new data science center, which is where BI&A is taught and BI&A jobs come from. The focus of business intelligence and analytics is understanding and interpreting data, then strategizing and taking action to improve business interests. This includes many other academic disciplines like information systems, computer sciences, statistics, management, and marketing. Information systems programs are very beneficial to training a new generation of business analytics professionals. Focus has shifted from the management of internal business and data to data analysis and rapid-fire decision-making based on an immense amount of data. The questions that information systems professionals must ask themselves when looking into training the next generation are what kind of student they're looking for, should they be math and science savvy, and if the information systems classes would even suit the needs of the new generation of decision makers. The skills that businesses look for when hiring business intelligence and analytics professionals include critical analytic and information technology skills, business and domain knowledge, and great communication skills. These are all required in a business where the data is extensive and complex. Three programs that could be developed for business intelligence and analytics would be a Master's of Science degree in Business Intelligence and Analytics. Universities that have already undertaken this task include North Carolina State University, St. Joseph's University, Northwestern University, the University of Denver, the Stevens Institute of Technology, and Fordham University. A Business Intelligence and Analytics concentration in already existing Masters of Science Information Systems programs would supplement this program greatly, and universities that have included this are the Carnegie Mellon University and the University of Arizona. The third option, a graduate business intelligence and analytics certificate program, would be a quick way for already established professionals to brush up their skills. This option could be made available online, which would be very attractive to a working adult. Northwestern University's Masters of Science in Predictive Analytics and Stanford University's Graduate Certificate on Mining Big Data are two programs already in place.
Business intelligence and analytics, from big data to big impact. Summary. The evolution of BI&A from the 1970s and statistical methods used were transformed with data mining techniques of the 1980s. The 1990s, with the analytical techniques that were used and evolving World Wide Web and digital transformation into present day, has had a tremendous impact on the field. The BI&A application discusses such techniques and tools that were applied during this time frame, and also the research framework goes into analyzing all of those different features that emerged during the evolution from the 1970s to present day. Mapping the BI and A knowledge landscape discusses how scholarly journals and other publications impact not only improvements in data analysis and business intelligence, but also how these elements have been documented along the timeline of its evolution. In the United States, we have a shortage of data-savvy managers and of business professionals with deep analytical skills. With the new developments in BI&A education and development, we can acquire the skills that we need to have to become savvy and to become those data-savvy managers.
This whole article has taught us about the evolution, application, research framework, knowledge landscape, and education and development of business intelligence and analytics. It is quite a long journey it has already been, and the capabilities of analytics compared to even 5 years ago continue to expand horizons and possibilities. We would like you to consider the following questions and comment if you'd like so we understand your opinion on the evolution and future of business intelligence and analytics. First, what do you think has been the most impactful part of the evolution of business analytics and why? You can choose from Business Intelligence and Analytics 1.0, 2.0, or 3.0. The second question is please consider what application of business intelligence and analytics has the biggest future possibilities and why? Choosing from e-commerce and market intelligence, e-government and politics 2.0, science and technology, smart health and well-being, or security and public safety. Thanks.